Our world is absolutely full of massive steel structures. Think about the Golden Gate Bridge or giant oil tankers. They're everywhere, but these things are in a constant fight against their biggest enemy, corrosion, rust. And their main line of defense, the shield that keeps them safe, is actually something you can't even see. It all starts with this process of incredible force and precision, a process that creates a hidden landscape on the steel itself. And that's exactly what we're going to dive into today.
It sounds almost laughably simple, right? You just paint it. But think about it. How do you get that coating to hold on for dear life for decades through all the rain and salt and blistering sun without just peeling off? Well, the secret isn't actually in the paint. It's in preparing the surface with a method that sounds completely backward. You have to make it rougher.
So here's how we're going to break it all down. First, we'll talk about the main goal, why grip is so much better than slip. Then we'll look at the seriously cool tools they use. After that, we'll get into how they judge the surface to know it's done right. We'll also cover when you might want to add water to the mix. And finally, we'll talk about the inspector, who plays an absolutely critical role in all of this. All right, let's jump right into that fundamental goal. You see, it turns out that for a heavy-duty, high-performance coating, a perfectly smooth, glassy surface is pretty much the worst thing you can possibly have. You need to create a surface that the paint can literally grab onto. And that brings us to the core concept, surface preparation. It really has two jobs that are equally important. Job number one, get the steel totally, completely clean. We're talking no rust, no old paint, no grease, nothing. Job number two, create a very specific texture, a kind of roughness that gives the new coating something to anchor itself to. And this is what it looks like when you zoom way in. This jagged, rugged surface is called the anchor profile. And those little peaks and valleys, they are everything. They dramatically increase the surface area and give the coating literally thousands of points to lock onto. See, it's not a chemical bond, it's a powerful mechanical bond. It's pure physical grip. So how in the world do you create that perfect anchor profile? Well, you need a toolkit that's a wild combination of raw power and really fine-tuned engineering. Now, I know, at first glance, it just looks like a bunch of hoses and tanks. But what you're really looking at is a perfectly calibrated system that's designed to turn tiny particles of grit into a weapon of precision. Every single component here, from that huge compressor all the way to the tiny tip of the nozzle, plays a vital role. It's like a chain reaction of power, and it happens in 5 clear steps. First, the air compressor makes a ton of high-speed air. Second, a dryer yanks out any moisture. That's key. Third, the blast pot is where the abrasive grit gets mixed in. Fourth, that whole mixture rockets down the blast hose. And that leads to the 5th and final step, the nozzle, where that mixture gets fired out at over 400 miles per hour. Just imagine that force. Hitting a surface with that much power is one thing, but how do you actually know when to stop? How clean is clean enough? Well, this isn't guesswork at all. It's a science, and it's governed by some really strict international standards. You see, you can't know where you're going if you don't know where you're starting from. So before a single grain of abrasive is blasted, an inspector comes in and does a really detailed assessment of the steel's condition. They're looking for rust, of course, but also old paint, and something called mill scale, which is just leftover stuff from when the steel was made. And they don't just eyeball it and say, yep, that looks rusty. No way. They use these standardized visual guides, like the ones you see here from SSPC and ISO. These photos basically create a common language for everyone on the job. Is the surface a condition A, with just a little bit of scale? Or is it all the way to a condition D, totally covered in rust and pits? That initial grade changes the whole plan. Then, after the blasting is all done, the inspector comes back with another set of standards to grade the final product. You've got different levels here, from a basic brush-off clean all the way up to white metal, which is the absolute cleanest you can get. Now, as you can see, the names are a little different between the standards. Like SSPC SP5 is pretty much the same as ISO's SA3, but they're all describing a very specific visual outcome for what clean really looks like. Okay, so that fire hose of dry grit we've been talking about isn't the only tool in the toolbox. Sometimes the job calls for a slightly different approach, and a lot of the time, that means adding water into the mix. So here is the main trade-off. Dry blasting is super fast, super effective, but it kicks up a giant cloud of dust, which can be a huge problem for health and the environment. Now, wet abrasive blasting, or WAB, solves that problem by mixing water into the stream. The water traps the dust particles so they just fall to the ground. But there's a catch. The second that perfectly clean, wet steel is exposed to the air, it wants to rust instantly. It's a phenomenon called flash rust, and it means you're in a race against the clock to get that coating on. And then you have a third method, water jetting. This one is different, and you really got to understand this part. With water jetting, there is no abrasive media. Zero. It's just water at an unbelievably high pressure. It is amazing for stripping off old paint or washing away nasty contaminants like salt. But, and this is the absolute most important thing to remember, water jetting does not create a new anchor profile. It can only clean off an old one that was already there. That makes it great for maintenance, but totally useless on brand new, smooth steel. Look, all this amazing technology and all these precise standards, they're only as good as the person who is actually verifying the work. And that brings us to our final and maybe the most important piece of this entire puzzle, the coating inspector. An inspector's job is so much more than just looking. Before any work even starts, they're checking things like the dew point. Why? Because if the steel is too cold, moisture from the air will condense on it and it will rust in minutes. During the job, they are constantly monitoring the conditions. And afterwards, they don't just look, they measure. They actually measure the depth of the anchor profile with special gauges. They even use this special tape to check for invisible dust on the surface, because even a tiny, microscopic layer of dust can cause a multi-million-dollar coating job to fail down the road. So, the next time you drive over a massive steel bridge or see a ship in a harbor, just remember that violent, precise, and totally invisible process that creates its most important line of defense. That anchor profile is the real unsung hero. And it kind of makes you wonder, right? What other hidden processes, what other invisible feats of engineering are out there quietly protecting our world every single day?